Hey everybody, we are balancing equations today, and these are our set of 4 rules that we use to balance equations, kind of the process that we'll go through to balance each equation. Now, once you get the hang of it, everybody kind of balances equations differently, but this is one of the best ways to go through it and to make sure you count all the atoms correctly and don't miss anything. So our 4 steps, we have 2 sides of an equation, right? The left side are the reactants and the right side are the products. You want to count the number of each type of atom on each side, first on the left side or the reactant side, then on the right side or the product side. And how we count those atoms is using the subscript right here. So if I flash to an example problem that you'll see in a minute, if we were going to count the atoms, we would draw a line down the middle here, and we would count the number of carbon atoms, the number of hydrogen atoms, and the number of oxygen atoms on each side, because those are the only 3 elements we have. We have C, H, and O. So we'd write those down, C, H, and O. And then to count the number of atoms, we count these small subscripts right here. So carbon, there are 2 on this side. I'm just going to go through and count them. Carbon, there are 2 right here. Hydrogen, there are 6. Oxygen, there are 2. On this side, carbon, there is 1. Hydrogen, there is 2. And oxygen, there are, you got to count both. So you have 2 oxygens right here and 1 oxygen right here. So there's a total of 3. So you look at every individual element, regardless if it's in a compound or not, and see what its subscript is, which the subscript is this little number right here. And that's the number of atoms of that type of element that are on that side. So carbon, there are 2. Hydrogen, 6. Oxygen, 2. Then over here, you got to make sure you count oxygen here. There's 2, and oxygen here. There's 1. If there's no subscript, that means there is 1 type of that, or that 1 atom of that element. So that is our first step: is we count the number on the left side and the number on the right side. Our second step is look at the atoms on each side and see if they are equal. Are they equal? Carbon, there's 1 here. There's carbon, there's 2 here, and carbon, there is 1 here. Are those equal? No. Hydrogen, there is 6 here. Hydrogen, there is 2 here. Are those equal? No. Oxygen 2, oxygen 3, no. None of these are equal. Our goal of balancing equations is to get this number of carbon the same as it is over here. 2 carbons over here and 2 carbons over here. The same number. When we do this, our step 3, once we get ready to start balancing the equations, you always leave hydrogen and oxygen for last. So here, we're going to try to balance the carbons first, and we're going to leave hydrogen and oxygen for last. We're not going to worry about those until after we have balanced carbon. Now, how do we balance them? How in the world are we going to get those equal? Well, you do that by adding what are called coefficients to make the numbers equal. Now, I've labeled it right here. This says 2H2. The large 2 in front of this H2, this is a coefficient. How the coefficient affects the element itself and the number of atoms. You have the subscript right here, which the subscript is a small 2. That would mean without this coefficient, there would be 2 hydrogens, right? Well, when you put this coefficient on here, what you do is you multiply the coefficient. You have 2, the big 2 right here, and you multiply it by whichever number is in the subscript. So here it would go from having 2 hydrogens, then we add this coefficient of 2. You would do 2 times 2, and then we have 4 hydrogens. So once you add that coefficient, it multiplies the number of atoms that you have of that specific element by doing the coefficient times the subscript. So the big number times the little number. So we can add those larger numbers, those coefficients, and that's going to help us determine the number of atoms that are found in each element type. So we're going to work on adding coefficients to get the numbers equal. So here, I'm just going to do a brief part of this example, and then there will be separate videos for the other examples. But if we were going to add coefficients, I'll just show you how we would make carbon equal. Carbon is 2 over here and 1 over here. Meaning, let's focus on this side. Whichever side there is less of, like there's 1 carbon over here versus 2 over here, we want to try to get this 1 to equal this 2. How can we do that? Well, if we add the coefficient 2 right here in front of carbon, then suddenly 2 times 1, that's going to give us 2 carbons, right? So now suddenly these are equal. Yay, go team. So that's how we can get the carbons equal. Now, you should know every time you add a coefficient in front of a compound, it affects the entire compound. So if we add a 2 in front of CO2, we have to address the O, and you have 2 times 2, which equals 4. So that's going to change our oxygens from 3 to, we got 4 right here and then 1 right here, so that's going to change it to 5, so those aren't equal. Now that's just a brief example of adding a coefficient in front of the C. I am not going to finish this example right now. I just wanted to go through the rules with you. For the practice problems, you look at the different practice problem videos. So those are the basic rules. Make sure you have those down and make sure you know what a coefficient is and how that affects a subscript. And go watch some practice problems. See you later.